My name is Elisa Manning, and I'm really pleased to be presenting to you from Biodata Catalyst powered by Terra. The topic of today's presentation is how to use data tables in a Terra workspace for workflow input and output. I'll be showing some advanced features that allow you to gather data flexibly in our data table to use as an input. So uh, let me give a short introduction to Terra and what we'll be working on today. So Biodata Catalyst, powered by Terra, is a cloud-native analysis platform, one of two analysis platforms that we have in Biodata Catalyst. Um, why should you consider using BDC Terra, or who should consider using BDC Terra is a question we often get. Now, first, I would say that if as long as you want to use BDC hosted data sets, not consortia data managed by BDC Terra or BDC, then BDC Terra is a place for you. On our BDC powered by 7 bridges, we have consortia data managed by BDC. Another reason you should consider using BDC Terra is if you are already using Terra or the NHGRI's Anvil, which is also on the Terra platform, or if you want to combine data sets that are available in Terra. The prerequisites for today's demo, although I am using open access data, if you want to replicate this demo or do something similar with controlled access data hosted in Biodata Catalyst, then you must have an approved data access request in dbGaP. When you log into the BDC Powered by Terra platform, in order to leverage BDC hosted data, your profile must be linked to the NHLBI Biodata Catalyst framework services. I'm providing a couple getting started documentation pages from both BDC and BDC Terra. Now, if we are going to leverage data tables for workflow input and output, I thought I should briefly introduce the workflow definition language, WDL, which is the tool that we use to write workflows. So WDLs are readable and simple and allow for some seamless integration with Terra data tables. I'm providing here an example task of one component of the workflow that I plan on presenting today, where you can clearly see what the task inputs are, being files, integers, or strings. The command, which you can read your very familiar Unix or Linux-like commands written out. So this particular component of our workflow runs 2 plink commands. So if you're familiar with a genomic analysis tool called plink, you would be able to read and understand this command. The output of this task are a number of files, and there are some runtime parameters for the cloud environment that include a Docker image, disk parameters, and required memory for this particular task. So every workflow written in WDL is comprised of many tasks, which you can see are human readable. So the analysis steps that I'll show you today is first exporting data from Biodata Catalyst powered by Gen 3, the platform where many of the files that are hosted in Biodata Catalyst are managed and stored, curated, and exportable. I'm going to show you how a workflow is set up in a Terra workspace. I'm going to show you how I'm going to configure the workflow inputs and outputs, and then I'm going to run the inflow workflow. So let me jump into our live demo. First, starting from Biodata Catalyst powered by Gen 3. So here we are in the exploration section of the Biodata Catalyst powered by Gen 3 platform. I've clicked on files, and I am going to filter to our open access program data. I'm going to select the Open Access 1000 Genomes project, and then I'm going to select the variant calling reference, the VCF files associated with this project. And so what I'd like to highlight is that there are 50 files. Um, each file, as you can see in this table, there's a specific name that includes a chromosome and a label. Here it's recalibrated variants annotated. You can contrast that with a file right below it, which the file name includes a chromosome and then a label, which is recalibrated variants.vcf. So this is going to be important because I'm going to want to grab all chromosome files related to a single type, the recalibrated variants VCF, not the recalibrated variants annotated VCF. But uh, right now, I'm going to export everything, all these data types from this open access project to Terra. So if I were to click on this button, I would be brought to a series of windows asking me questions and setting up a workspace, but I'm going to go directly to a workspace where this has been done already. So I've completed the export into this workspace. So our workspace has several different components, all here on different buttons or tabs in the workspace user interface. I have previously edited the dashboard to note that this workspace contains the Create PCA Projection WDL from the Prime Consortium. So the workflow that we're going to run today is a common workflow or work stream or pipeline employed in statistical genetics, which is to generate principal components from genomic data in a cohort setting. Now, if I click on the data tab, we're going to see a series of tables here. And I'd like to map or relate this to what we looked at, saw in the Gen 3 platform. And you'll see that there's a table for program, and this is listing our open access, a table for project, we have 1,000 genomes, and a table for reference files, which you'll see is a large table with lots of metadata related to our projects, including file name, file size, and the link to the file as hosted in Biodata Catalyst. So this is the mechanism through which we're going to use a file as input to our workflow. It's these particular links to the file, which we call DIRS URIs in Biodata Catalyst. I'm going to just show you a couple nice features of this data table. I may not want to see all these columns. I may only want to see file name, file size, and DIRS URI. So I've gone to the settings, selected the columns that I want, and now you'll see that in the data table, I only have those 3 columns in the view. Note again that I want to only use some of these files for our input to my workflow. I do not want to use the recalibrated variants annotated files. I want to use the files that have the term recalibrated variants. Let me go to the workflow so we can take a quick preview of how inputs and outputs are represented. There are a series of input parameters, and if you're interested in learning and reading the WDL, there are a couple features here. You can look at the workflow script, read this directly, or you can follow links to the actual code that you can then use to in this particular example, read particular files and learn more about the workflow. So going back to where we were in the workflow configuration, what I need for our inputs, that the required input here is an array of files that are VCF files, one for each autosomal chromosome. And the task is to get to this particular input. So I'm going to do this fairly quickly since I'm going to go back to the table. I am going to search for the term recalibrated variants.vcf. And now I have filtered to only those tables. I'm going to select all. And because I know that I do not want chromosome X or Y, I just want autosomal chromosomes, I'm going to unselect several rows. And then from these, I'm going to click on edit and say save selection as set. So I'm going to call this VCF autosomal. I'm going to save it. And now I have a new table, which is called the reference file set with the name that I just entered, but it's pointing to those rows in our reference file that I'm interested in using as an input to my workflow. So now I'm going to go to my workflow. I have selected to run the workflow with inputs defined by data table. I'm going to select my reference file set and then select that set that I just created. I then have to enter something into this input value, and I'm going to select the dir URI for each reference file through this nice, easy to use mechanism. Could save this. I want to be able to organize the outputs of this workflow. So I'm using this mechanism called using the term this dot and then a column name to save these new columns to the workflow that the table that we just created when this workflow runs. So I would launch this and get it up and running. And now I could see it run. And in the interest of time, I'm going to pull up a workflow that we've already that I've already have up and running. I can do that quite easily by going to my workspaces and then pulling it up. So this is what we have here is a successful run of the workflow that shows the entity that I used. And if I wanted to explore the output, I would simply go to our reference file step that I just created. And now I can see a number of columns that were just created by the successful run of the workflow, including some nice visualizations like PCA plots. In Terra, you can quickly reference and preview some of these files. And then importantly, I can show the provenance of the value from the table. And you can see that this particular column was created by the Create PCA Projection workflow run on May 26th today. So we can easily keep track of how these columns were created.